So I have to start right off the bat and ask, is this room, am I talking to a bunch of economists in this room this morning? Any yeses, nos? And I hope not, because the economists need to be at Wall Street solving our problems this morning, right? While we're in here talking. And the first thing that I got to tell you is, when I sat down with my staff a few weeks ago, we said, what do we want to talk about at this keynote? I said, we've got this whole portable design issue with power and the supply of power and the demand of power. It's difficult. It's thorny. Started going through some of the solutions and some of the things that are near term and far term. And one of the staff members jumps up, and he's a pretty smart guy. His name's Pavan. He jumps up and he says, "Jim, this is simple. This is all about supply and demand. This is economics 101. He jumps up and draws this whole supply and demand chart, just like the one that's beyond right here. He draws this whole thing. He's very articulate. He shows where the supply is, where the demand curve is. He sounds like Milton Friedman. By the time we're done, I'm sitting there thinking two things. I'm back in college, which I had a lot of fun in college. And the second thing is, we're going to end up talking to economists. Well, we started working through the issues. We started talking about those problems. And eventually, it became obvious we weren't going to have a presentation for economists. Because economists, when you talk about solving the demand, well, they can do that. They can decrease demand. And when you talk about the supply, yeah, they can increase that too. It's pretty doable. Well, can you do both? Well, they can do that too. When you look at what the engineers have to do for portable design, and even more specifically to handsets, which have the thorniest issues, reducing the demand, whether it be components or system, is pretty difficult. Doable, but difficult. How about increasing the supply? It's arduous. How about doing both? It's flippin' Herculean. So I knew now before I got here, after we had that discussion, I'm not talking to economics, I'm talking to engineers, because it takes an engineer to solve these problems. Now, if there's an economist in the room, I'm not going to apologize. So let's talk about, today we're going to talk about those problems, the power problems. We'll talk about some of the solutions, the near term, the short term. We'll talk about from the supply side. We'll talk about from the demand side. We'll talk about future benchmarks and how the designs for components and for systems should be designed keeping in mind what those future benchmarks are. Because those future benchmarks, they aren't here yet. And also designing for green and what that really means, even for portable consumer electronics. And then a conclusion. So before I get into the big thorny problems, you've got to start off with this whole issue of convergence. We all are aware of convergence, right? We're taking our handset and we're making it our computer, our phone, our television. Your handset now can do many things. The video you can watch, you can surf the internet, you can do your banking, you can do text messaging. It's endless. And that whole process of convergence is what drives the energy issues in a handset. So the chart above you shows that the energy demand in a handset is increasing dramatically. It's virtually outstripping the supply, and in this case, it's a battery. Now, we all know that a battery is a material science, and it improves at a rate of about 5-6% a year. Not nearly as much as what we're seeing in energy consumption in the handset from convergence, which from some estimates is 25% and higher. This is the curve that I just talked about, where you actually have the handset, the energy consumption, actually outstripping the capability of the supply, the battery in this case. So let's take another step and look a little bit more into the details of this. And when I use examples for today, I'm going to focus on handsets because it is the largest portable consumer electronic device unit-wise, and it's the one that has the thorniest problems, as John mentioned earlier. But if you look at a handset, the first thing you have to do is to identify where can you save on energy. You have to look at the activity that the handset's performing, whether it be voice, web browsing, text messaging, or Wi-Fi, for example, are the four examples that I have on the screen here. And you can get an idea what the processor's taking, and it's not too bad. And you can see where that radio is. And the radio gets to be bad where you know it's going to be, on the voice and when you're text messaging, or actually with Wi-Fi. Wi-Fi and voice for the radio are the toughest for it. But there's another one, and it's broken out by two here. Panel power and backlight. Put those together, that's your display, a typical LCD. And if you notice, they tend to be a pretty big violator throughout the entire process. Not so much on voice, because the display is off. But for web browsing and for texting and for Wi-Fi, it tends to be a pretty big consumer of the energy. So let's take a deeper look at that. How big of a consumer? 73%. During the activity of text messaging, 73% of the energy during that activity goes to support the display. So you say, well, okay, so got some burn in the display. How often is that thing on? Mind you, the display is still the main interface between man and machine. Is that activity going to increase? Well, convergence says it is, and so do the data tracking. Back in 2005, those activities that required the display to be on required 16.5% of the energy budget. By 2011, those activities that require the display to be on will be far above 40%. So the energy consumption that you see in a handset now, when you look at those components, the processor, the radio, and the display will only become more and more and more of an impact on the energy consumption and the energy budget that you're designing for. So what are some of the solutions? And I think we're all comfortable. I think we all know what these problems are. You suffer those every day. You design around them. What are some of the problems or some of the solutions? The first solution is we put in a bigger battery. Right off the bat, 3G phones, 20% of them, they just put in a bigger battery. That makes sense, right? Need more power? Put in a bigger battery. That's a lot better idea than getting a longer cord for AC charging. But the bigger battery doesn't actually help. It makes it even harder for the mechanical designers. The bigger battery, either one makes it thicker and heavier, or it makes it wider. And it's completely against the whole style value proposition of a handset. That's one of the three key factors in making a successful cell phone design a successful seller, is the design itself. And a bigger battery goes and trashes that. Are there other solutions? Absolutely. Some of the near-term solutions that you're aware of today, there's process scaling. We've seen the benefits of that over the years. We've seen dynamic voltage and frequency scaling, basically an adaptive processor. We've seen more efficient amplifiers, and there will be more, and adaptive backlight control. These you're all familiar with. What I want you to take away from this is those are difficult. They're not just easy to get. They're complex, and they do add cost. But you have to do it because it's the low-hanging fruit that everyone can see, and it's what you have to put in now. The result of that, the aggregate, if you've got all of those, you might be able to reduce that energy consumption, that demand, down by 20%. It's just a little nit in what needs to happen. Just a nit in where we need to get that demand down.